In the last section, we put together a little code snippet that demonstrated some pretty interesting or surprising behavior. We created a brand new slice, we passed it off to the update slice function, we then updated the slice and then printed out the original one. When we printed out this original slice right here, we saw that the first element had been changed by the update slice function, which is completely opposite from what we have been seeing with a struct. So remember, with our struct, when we passed it off to the function, Go internally made a copy of the entire struct. And so when we modified it in the function, we were modifying the copy, not the original struct. And so it appears that the slice is working significantly differently. So let's figure out exactly what's going on here. Now we're going to look at a couple different diagrams. And the first thing we're going to figure out is what the difference is between an array and a slice in Go. So this is going to be a little bit of a tangent, but trust me, it's all related to this pointer stuff. So at this point in the course, we've only been making direct use of slices. But to be 100% clear, Go has access to both slices and arrays. We rarely use arrays directly because it is seen as a very primitive data structure, mostly because arrays cannot be resized. And so it's not incredibly often that we ever want to make a list of items that is of fixed length. Usually we want to make a list of items that can grow or shrink over time as required by our code. So 99% of the time, we are always making use of slices, and we rarely ever make arrays directly. Now you can think of a slice as being like a fancy array. And in truth, behind the scenes, a slice actually kind of is an array. So when you and I create a slice, Go internally is creating two separate data structures for us. So in this slide right here, at the top, we've got where we declared our new slice of string. Here's that declaration right here. So when we make this slice of string, Go internally is creating two separate data structures. The first is what we refer to as the slice. The slice is a data structure that has three elements inside of it. It has a pointer, a capacity number, and a length number. The length represents how many elements currently exist inside the slice. The capacity is how many elements it can contain at present. And this pointer right here is a pointer over to the underlying array that represents the actual list of items. So again, when we make a slice, we get both the slice data structure, and Go also makes an array internally to represent all of our different items. So that's kind of element number one to understand. We get both a slice data structure and an array anytime we make a slice. Now let's take a minute to kind of think about how all this data will get stored in memory. So we're going to look at this diagram right here. Now, just like when we were talking about pointers a little bit ago, this diagram of how memory on our machine is working is not 100% accurate, but for the purposes of this discussion, it's certainly like enough to convey what we're trying to say here. So we can kind of imagine that whenever we create a slice in Go, Go will automatically create that little slice data structure that has the length, capacity, and a pointer to the array in one address in memory. And then that data structure is going to have a pointer over to the actual underlying array, which it will be existing at a completely separate address in memory. Now, our mySlice variable up here is not pointing at the underlying array. Whenever we refer to mySlice, it is actually returning the slice data structure, not the array. And so I want you to think a little bit about what happens when we call a function and pass mySlice into it. Well, when we call a function and pass mySlice into it, Go is still behaving as a pass-by-value language. So Go is still making a copy of that value. So when we call the update slice function and pass in our slice, we take the slice data structure and copy it off to another address in memory. But here's the crux. Here's the really crazy thing. Here's the very important thing. Even though the slice data structure is copied, it is still pointing at the original array in memory because the slice data structure and the array data structure are two separate elements in memory. So yeah, we are copying the slice, but it is still pointing at the same array. So when we modify this array, or when we, inside the function, when we attempt to modify the slice, is what I mean to say, we are still modifying the same array that both copies of the slice are now pointing to. Now here's the real gotcha. In Go, slices are not the only data structure that behave in this fashion. There are actually several other types of elements that behave in exactly the same way, where the underlying data structure or the value that we create is kind of this, what we refer to as a reference type. So the slice data structure right here is what we refer to as a reference type because it is a reference to another data structure in memory. And so it's totally okay if we make a copy of this reference in memory because it's still always going to be pointing back to the same underlying true source of data. So in Go, slices are what we refer to as a reference type. Now there are several other reference types that we'll make use of over time. So maps, which is something we still have yet to talk about, channels, which we've not spoken about yet, pointers are a reference type, and we've been making use of those. And then we haven't seen it just yet, but functions can be passed around as arguments to a function, and those are also a reference type. Now at this point, we've been working with ints, floats, strings, booleans, and structs, and these all behave as value types. So in other words, if you are passing an int, a numeric type, a boolean, or a struct off to a function, that means that you do want to think about all this pointer stuff that we've been discussing. But if you're using one of these reference types over here, we don't have to worry about pointers because whenever we pass these types of values around, Go is going to say, oh, well, this is a reference type, still gonna make the copy, but they're still referencing the same underlying value structure in memory. So this is the big gotcha. This is the very confusing part. If I were you, I would probably take a screenshot of this list right here, or I don't know, write it down, take a couple notes, because honestly, you're going to probably run into this issue many, many times when you start running some code. So all you have to remember is these basic types plus structs. We do have to worry about pointers if we want to change the underlying value, but if we are working with slices, maps, or channels, then hey, no need to really consider pointers in these cases. Okay, so that's the big gotcha. Hopefully it's not too crazy. Again, the thing to just keep in mind here that, yeah, Go is still making a copy of the variable or the thing we're passing off to this other function, but that thing that we're making the copy of is still referencing the same underlying source of data in memory, which is why we can freely change it and see that array actually be updated. All right, so that's pretty much it for the big gotcha. Let's continue on with our next topic in the next section.